Electrical machinery 1. Separation of core losses. DC motor. Electrical machinery 1. DC motor. Separation of core losses. Application of DC motors. DC machines, generator or motor. The losses classified into three categories, namely copper losses, iron or core losses, mechanical losses. Iron losses. Iron losses occur at core of the armature of a DC machine due to rotation of the armature in the magnetic field. These losses occur in core of the armature. These are also called core losses. Core losses has two types or iron losses, that is hysteresis losses, first, second, eddy current losses. Mechanical losses. Power losses due to friction and windage in a DC machine are known as mechanical losses. Stay losses. Iron or core losses and mechanical losses together are known as stay losses. Separation losses in a DC shunt machine. Mechanical losses depend upon RPM, whereas iron losses depend upon RPM and also magnetic field. Intensity inside the machine. The following and steps will show the method of determining mechanical losses and rated RPM. And also the iron losses are rated RPM, rated field current. Armature diagram shown in figure. Consider armature rotating at a speed slightly greater than rated RPM without excitation and assume that the supply to the machine in cutoff when the armature will slow down. Kinetic energy in the armature of I omega squared. W is where I is moment of inertia. Omega is radian. Omega is 2 pi n divided by 60. Circuit diagram shown in figure. D omega divided by dt is ratio of loss of energy, mechanical loss in watts. When the armature is going down, it will lose energy, so there will be a loss of power. This power loss is called frictional and windage loss. Mechanical power loss. Mechanical power loss is equal to d divided by dt of half into I omega square. I omega d omega divided by dt. I 2 pi n divided by 60 into d by dt of 2 pi n divided by 60. Mechanical power loss is equal to I 2 pi divided by 60 the whole square n dn by dt. Mechanical power loss is equal to I into 2 pi divided by 60 the whole square into n dn by dt. This formula shows that we can find out the mechanical loss is if we know the value of I and also del n divided by del t. Graph shown time versus speed. That given the slope is given the loss of mechanical loss. Slope is OA divided by OB. Slope of the curve given value OA divided by OB. Slope of the tangent is given by OA divided by OB. This following procedure will enable us to determine iron loss plus mechanical loss at rated RPM from the machine with rated field current in the armature and also an RPM slightly above the rated RPM. Then discard only armature part. Don't discard the field current. Machines close down and loses the energy. This loss of energy is an account of mechanical losses and also iron losses. Graph is obtained from speed versus time curve, that the given value of rated speed with rated excitation curve we obtained from graph. Iron loss plus mechanical loss is equal to I into 2 pi divided by 60 whole square n dn by dt. dn by dt power 1 is given by the slope of the tangent OA divided by OB. Thus we can found out iron loss plus mechanical loss at rated RPM by subtracting mechanical loss from this already calculated in the previous step. We can find out the ideal loss at rated RPM at rated excitation. By subtracting the mechanical loss from this, we can find out the ideal loss at rated RPM at rated excitation.